Thank you so much for joining this lesson. I invite you to today's lesson, which is the Color Joint Trial Examination 2025. Those who don't know about color, this is a joint examination which has been done by 4 schools. That is the Kenya High, Alliance High, Lenana School, and Alliance Girls. So we're going to revise the paper, and it's my hope that people are going to benefit from the platform. Feel free to subscribe to this platform. Remember to share so that you may invite a friend. As we continue learning, let me invite you to our August holiday program. We have organized a very serious program for secondary school students. You can register through my number 0704 15 3366. This one is going to be very engaging. We are bringing on board experts in the sciences, in the languages, and also in mathematics. So kindly be one of us and get the best from the best. Back to the paper now. Number 1, solve for x, given that 2x over negative 2 equals to x minus 6 divided by x. So let's look at the possible solution of this question. The first thing that you should do here is to do a cross multiplication, whereby 2x multiplies x, then negative 2 multiplies x minus 6. That way, that's a cross multiplication now. At this point, you just cross multiply. Then you can now expand by opening the brackets. 2x squared equals to negative 2x positive 12. Yeah, when you multiply negative 2 and negative 6, we get a positive. At this point now, we can observe that the equation is quadratic in nature. So we can rearrange it so that it takes the right format of a quadratic equation. That is, we begin with the term that has 2x squared. So this is going to be 2x power 2 positive 2x minus 12. This is equivalent to 0. The equation can be solved at that point, but looking at how it has been structured, you can notice that there is a common factor, that is 2. So 2 can be factorized such that when we divide it through by 2, we are getting x squared plus x minus 6 equals to 0. So this now can be solved using any of the several methods of solving quadratic equations. Allow me use the factorization method now that we are dealing with Form 2 work. This is a paper 1. So for us to work together with Form 2 students, I'm going to use factorization method. Remember, there is the quadratic formula in Form 3, and there is also completing the square method in Form 3. So at this point now, I will need a product of A times C. At A we have 1, and at C we have negative 6. You know, we usually say that the general format of a quadratic equation is ax squared plus bx plus c equals to 0. Therefore, we need a product which is equal to a times c, the constant there. So the coefficient of x squared is what we are calling a, and that is 1. Then the constant c is a negative 6. That gives us negative 6. Then we need a product, that's a product equal to a times c, then sum, which is equal to the value at b. The value at b is usually the coefficient of x. And this coefficient of x in our equation is 1. So now we need 2 factors, which when multiplied, they give us negative 6. And when added, they give us a positive 1. And these are going to be 3 and negative 2. 3, negative 2. When you multiply, negative 6. When you add, positive 1. So at this point now, we can rewrite our quadratic equation now, such that we begin with x squared, then x can now be split into 3x minus 2x. So that is a re-expression of what x is, because 3x minus 2x would still mean x. -6 equals to 0. At this point, ladies and gentlemen, we are supposed to factor out whatever is common for every two terms. So for the first two terms, what is common here? X. Then we remain with x plus 3. Then in the other two, what is common? -2. So that will remain with x plus 3. This is equal to 0. At this point now, from the brackets, we can pick the common factors, which is x plus 3. Then outside the brackets, we are having x minus 2. This is equal to 0. So now, if x plus 3 multiplied by x minus 2 equals to 0, then it means one of the factors is a 0 or both of them. X plus 3 equals to 0, or x minus 2 is equal to 0. From the first, x equals to -3, or from the second, the value of x equals to +2. So now we are through with solving and finding the value of x. That's number 1. We can now proceed to check what number 2 demands. We are told to use logarithms. Correct to 4 decimal places to evaluate the cube root of 27.53 multiplied by the cosine of 38.45 degrees, then divide by 6.78 squared. Yeah, so I would request people to comment. Let's know where you are watching us from. Let's know whether you are getting something as we analyze this question together, the second question. And I'm going to make sure that the followers understand what we are doing at this point. So it's good for you to organize your working space very well when you are handling this type of a question. It's just good for you to have your space well organized so that you begin with the number, then the standard form of this number, then the logarithm. That too. So it's good to organize your work in such a manner. Which is the first number here? The first number is 27.53. So this number can be written in standard form, whereby it shall become 2.753 multiplied by 10 power 1. Then the logarithm begins with power 1, or it begins with 1. So on the characteristic part of the log, we have 1 point. Now we are supposed to find the logarithm of 2.753. The question is open. You've just been taught to use logarithms. So it means you can use the logarithms in the calculator or the logarithms in the mathematical tables. So it's good for us to interpret the 4-figure mathematical tables, and that is what I'm going to open right away. So let me check the 4-figure table. The 4-figure mathematical table. Yeah, it's here. Logarithms. So I'm going directly to the logarithms. Here we are on logs. We are finding the log of 2.753. So we first identify the row 2.7. Here it is. This is the row that we shall be using. 2.753. Yeah, 5 3s. So 5, the column that has 5 is here. Remember, it is 5, 3. So again, on the differences side, we go where there is 3. The column is here. So we check where that column intersects the row. It is here. Therefore, we shall be having 0.4393 and we add 5. 4393 and we add 5. We add 5 at this point. So it shall be 8,934. 0.4398. 4398. So we have extracted the logarithm of the first number from the 4-figure tables. Which is the second number? The second number is the cosine of 38.45. And at this point now, I want you to be very careful with whatever we are doing. At this point, we shall skip directly to the logarithms. Reason being, we have tables for logarithms of trigonometric ratios. So we go to the logarithm of cosines. The logarithms of cosines. Those were logarithms of natural numbers. So we have to go to logarithms of cosines. So logarithms of sines. Sines. So logarithms of cosines are here. So logarithm of cosine. Natural, these are natural cosines. So we have to continue natural tangents. Then we proceed. Yeah, logarithms of sines. Logarithms of sines again. Logarithms of cosines now are here. So this is the table that we need. Logarithms of sines. So we have to look at, or to look for, the logarithm of the cosine of 38.45. 38.45. Therefore, now I check the angle side, 38.45. So we identify the row like that. Then the columns now, respective columns, 38.45. So at 4, this is what we have. At 4, we are here. Then 5. So the differences side, where there is 5 now, we go down that column until we find there is a 3 here. On the differences side, we are supposed to subtract. This one is very key. We are subtracting, we are not adding. So when we pick, and it's good to also notice that we are beginning everything with bar 1 point, bar 1 point. This bar 1, not 1. In some of the cases, it is not very clear. So we are starting with bar 1. So it's bar 1.8941, and we subtract 3. Bar 1.8941. So we have bar 1, not negative 1, but bar 1.8941. Then we subtract 3 at this point. So this is going to be, we make it 11 first. 11 minus 3, 8. Then it's became 3 now. The 4 becomes 3. So 3, 9, 8, bar 1. So bar 1.8938. Yeah. So that is the logarithm of the cosine of 38.45. That's how you are supposed to move about that one. Now remember that 27.53 and the cosine of 38.45 have been multiplied at the numerator. They have been multiplied. Being multiplied, we should find the sum of their logarithms. So we add. And when we add this, I'm getting 16. So 6 carry 1. 9 plus 1 is 10 plus 3, 13. We carry 1 again. 3 plus 1 is a 4. Plus 9, 13. Carry 1 again. 5 plus 8. We get 13. So we carry 1. 1 plus 1, that is 2, plus bar 1. we get 1. Because bar 1 is like a negative 1. That way. Then we proceed now to the denominator, whereby the number there, 6.78. Remember, it has been squared. So this is a 6.78 times 10 power 0. 0 point. Now we read the logarithm of 6.78. The log of 6.78. 6.78. The log of 6.78. That is the row, 6.78. So 8. Now we come to this column with 8. What are we finding here? So it's a 0.8312. 8312, that way. Something else that you're supposed to note is that the denominator has been squared. When a number has been raised to a given power, we multiply the logarithm by that given power. So what we're supposed to do here is to multiply this logarithm by 2. Then we get the answer now. This is 4. This is 2. 6. 16. So we carry 1. 2 times 0 is a 0, then plus the 1 that we carried. So 1.6624. Now, after squaring, whereby we multiply by the power, then now we have to consider the numerator and the denominator have been divided. Therefore, the overall logarithm from the numerator, which is 1.3336, and the overall logarithm from the denominator, which is 1.6624. Due to the division, we are supposed to subtract these two logarithms. We are supposed to subtract them. Therefore, we are subtracting these two logarithms. And what are we getting? Let's proceed. 6 minus 4, this gives us 2. Then 3 minus 2, that gives us a 1. Then this is a 3 minus 6. We have to borrow 1 there to make it 13. 13 minus 6 will give us 7. Then this one became 2. So we can't subtract 2 and 6. We have to borrow 1 here, making it a 12. So 12 minus 6 is 6. This was 1 and we borrowed 1, so it became a 0. At this part, we are having a 0. So 0 minus 1, that becomes bar 1. Yeah, that becomes bar 1. Now, at this point, we are done with working out all the logarithms. After that, now we have to get the answer because we are having the final logarithm. Now we are supposed to work out the cube root there. When we are taking any root, we usually divide the final logarithm by that root. Therefore, we are supposed to divide by 1.6712 by 3. If it was overall square root, we would have divided by 2. If it was overall fourth root, we would have divided by 4. So that's how we handle the roots. About the power, whereby this is squared, and it is only that part which has been squared, then the logarithm for this one particular number, we multiplied it by the power. So we multiply by powers, but divide by the roots. I hope that one will help somebody. So now we are supposed to divide this final logarithm by 3. But the one thing that we're supposed to ask ourselves is the whole number a multiple of 3? Either 3 itself or 6 or such? And we find it is not. So if it is not, then we have to technically make it divisible by 3. It is already about 1, which is equivalent to a negative 1. So negative 1, we are supposed to check what can we subtract from bar 1 to make it divisible by 3. We subtract 2. So from bar 1, we borrow 2 again to make it bar 3. to make it bar 3. So that this one now will be divisible by 3. Then we add on the Mandisa part, which is 0.6716, the 2 that we've borrowed from the characteristic. Now we add it there. Instead of 0.672, now it becomes 2 point. We also divide that part by 3. So when we divide by 3, then we add, you discover that we are getting bar 1 point. 2.6712. We divide by 3. I'm getting 8904. 8904. So now this is the very final logarithms. But now we are not at the answer. So we have to get back now and find the number whose logarithm is this. If this is the log, then it means there is times 10 to the power of negative 1, because we are having a bar 1. If it was just 1, then it would have been 10 power 1. If it was bar 2, it would be 10 power 2, which is negative. All right. So at that point now we have to find the anti-logarithm of 8904. Anti-logarithm. So we go to the tables of antilogs. The tables of anti-logarithms. Just after logarithms, we talk about anti-log. 8904. I hope I'm remembering it. Yeah, 8904. The anti-log of 8904. 8904. 890, then 4. We add what is on this column with 4, which is a 7. Therefore, we shall be having the value here, and we add 7. 7.762. 7.762. Then we add a 7 at this point, and we shall be having 967. So 7.769. 7.769. That one. So now that is the standard form of the final answer. So the final answer itself shall be 0.7769. We've been told to 4 decimal places, right? So we are correct. So the final answer is 0.7769. That's how you're supposed to work out such a question. And it is my hope that you guys are learning something. Even Form 2s deserve such a lesson. So that is how you organize your work. One thing you're supposed to know is that in this particular learning area, it is really time consuming, but it guarantees some good marks to those who are very careful. Now at number 3, whole rectangular slabs of side 0.8 meters and 0.7 meters are used to cover the floor of a square garage. Calculate the number of slabs that are used to cover the garage. Look at this. We are having slabs that are rectangular. Allow me change these measurements from decimal points to whole numbers. We can do this by making them centimeters. So the slabs are measuring, to convert meters to centimeters, you have to multiply by 100. So this becomes 80 centimeters by 70 centimeters. So let's check the measurement of the garage. The measurement of the garage. So measurement of the garage is going to be measurement of the garage is going to be the LCM of 80 and 70. So 80 and 70, we find LCM, going to factorize this. I'll be explaining something about these particular settings. There are some settings which are brought such that you have to find either LCM or GCD. And in such cases, ladies and gentlemen, you're supposed to know this. What has been provided is a rectangular slab. Then this slab is going to cover a square room. That means the dimensions of the room are bigger than those of the slab. The dimensions of the room are bigger than those of the slab. Therefore, the slabs are multiples. The slabs are multiples of the room. They are multiples of the room. We need several to make the room. Therefore, the room should be bigger. And for that case, we get the LCM, a multiple. If we were given maybe the measurement of a rectangular floor, then it will be covered using square tiles or square slabs. Then it would mean that it is now the slabs which are not known and that they are smaller than the provided room. And in such a case, it means they should be able to divide the room into some number of them. And so we would get the GCD. But in this case, whereby we are given slabs and the slabs are covering a bigger room than themselves, then we need the LCM. The size of the room should be a multiple of the several slabs. So being a multiple, then we go for LCM, least common multiple. By 2, this is a 40. And by 2, this is a 45. We proceed by 2 again. 20, 35 is not divisible. By 2 again, we go to 10, 35 remains. By 2, we go to 5 and 35 remains. Then by 5 now, this is 1, this is a 7. And by 7, we shall have 1, 1. Therefore, the dimension of this garage is 2 by 2 by 2 by 2. I hope, yeah, 2, 2, 2, 2, 4 times. Then multiplied by 5 and by 7. So this will be the dimension of the square room. 2 power 4, then times 35, 560 centimeters. This is the measurement of the garage. So it means it's measuring centimeters. Calculate the number of slabs. So the number of slabs can be now obtained by taking number of slabs means area of room, or area of garage. This one we divide by area of one slab. So this is 560 by 560 out of 80 by 70. So let's get the number of slabs. 560 by 560, then we divide by 80 by 70. This gives us 56 of them. So 56 slabs are involved in this case. 56 slabs. That way. At number 4, represent the following inequalities in the grid provided. So we have a grid already provided. The axes have already been labeled. We are supposed to plot inequalities which have already been provided. Ladies and gentlemen, remember to subscribe, remember to comment. Let's know where you are following us from kindly. Let us know where you are following us from. Yeah. How many inequalities are we having here? 1, 2, 3, 4. 4 inequalities. So we're going to plot each. The first inequality, it is always very good for you to understand something, that we plot linear equations, which we call them borderlines, to represent inequalities. I hope that is clear. We represent linear inequalities using linear equations, and these linear equations are called borderlines. So we make it an equation so that it may give us a borderline. So the first inequality will be represented by y equals to 3x. Then, due to the nature of the inequality symbol, which is strictly less than, it means this is going to be a dotted line. It's good to recognize the type of a line it will be. If it was less than or equal to, it could have been complete. Like in the second case, it shall be a full line. But now in this case, it is going to be a dotted line. So now to plot this, we need some values of x and corresponding values of y according to the borderline equation. So if x is 0, it means y shall also be 0 because y will be 3 times 0, which is just 0. If x is 1, then y shall be 3 because the value of y is 3 times 1. If x is 2, then the value of y shall be 3 times 2, 6. These are enough coordinates. So we get to our Cartesian plane and plot 0, 0, 1, 3, and 2, 6. 0, 0, 1, 3, 2, 6. That is or those are some of the points where the line shall pass, and we're supposed to make it a dotted line. Very specific and categorical. You're supposed to know that. Yeah, so I'm done drawing the first borderline, which is dotted, and it is y equals to 3x. At that point now, it's also good for you to know which side of this borderline are we going to shed, or which side is unwanted, which one is wanted. So we pick one coordinate from any of the sides. Allow me pick a coordinate from here. This is coordinate 3, 3, for example. So if I fix 3, 3 in the inequality there, will it satisfy the sample? We are having y here, and we are having 3x here. Then where there is y, according to the coordinate I have picked 3, 3, I substitute 3. Where there is x, I substitute 3. So 3 times 3, that's a 9. So how are the two sides related? 3 is less than 9. And the inequality symbol used in this is less than. Therefore, the coordinate that we have picked is on the right side, is on the required side. That means now the other side of this line is not the wanted side, and so it should be dotted like that. It should be shaded that way. Number next, this is a borderline which is given us 2x minus 5y less than or equal to 10, which means that this will be represented by with an equal sign there, and it shall be a full line because the inequality symbol is less than or equal to. So with this now, we can find some values of x and y. Let me use what you call the intercepts. When x is 0, what shall be y? X is 0, so we substitute 0 where there is x. This part becomes 0. So we will say negative 5y equals to 10. And to remain with y, we divide by negative 5 through. So this becomes a negative 2. Then when y equals to 0, what shall be the value of x? So when y is 0, we shall substitute 0 at this point for us to get the value of x. So 2x equals to 10, meaning that the value of x shall be 5. Sorry, not 10. 2x equals to 10, so x shall be 5. So with these two coordinates, we can plot them, 0, negative 2, and 5, 0, and 5, 0. Remember, this time round, the borderline is supposed to be complete. So we did a complete borderline. Yeah, a complete borderline for this case. So we do a complete one. Like, should be complete like that. Now we're supposed to do what? We're supposed again to test the inequality sample using any coordinate. So if I use the coordinate 3, 3, again, then I shall feed it in the expression 2x minus 5, the value of y. Then the inequality symbol is known, not known. This is 6 minus 15. This is 10. This is negative 9. This is 10. How is negative 9 and 10 related? Negative 9 is less than 10. And so this means that the coordinate that we have picked, because we are getting less than, and according to how the inequality has been written, the same sample has been used, then it means the coordinate that we have picked is on the right side. And so we shed the other side because the coordinate that we've tested is on the right side. That way, it is on the right side. Are you commenting? Please comment. Let us know whether you are getting something from wherever you are. We have another borderline, which is going to represent x less than 4. X less than 4 will be represented by x equals to 4. And because of the nature of the inequality sample, this is going to be a dotted line. This is going to be a dotted line. So x equals to 4, we go to the x-axis and we identify equals to 4. Equals to 4, then we draw a line there. There's a line there. Yeah, this is x equals to 4 that way. So we can pick a coordinate like 3, 3. At 3, 3, the value of x is 3. Is 3 less than 4? Yes. So this is the required side. That means the other side should be shaded that way. And finally, there is 2y minus 9 equals to 0 to represent the final inequality. 2y minus 9 equals to 0. 2y minus 9 equals to 0, meaning 2y equals to 9, and hence y equals to 4.5. So the borderline that we are plotting is y equals to 4.5, and it's going to be full. It's going to be a full line. Remember, this one was supposed to be dotted, so I didn't ensure that, and I'm supposed to. So I ensure that this line is broken. This one was supposed to be broken. This one is a broken line that way. But now, the one that we are having this time around is going to be a full line. So on the y-axis, at 4.5 now, we draw a line through there. We draw a line through that point, a full line for this case. This is line y equals to 4.5. Y equals to 4.5. So now we can check again the coordinate 3, 3, whether it is on the required side for the line that we've just drawn. We just examine it. So in the process, then you shall discover this, that when we bring 3 here, it's going to be less. And if it's going to be less, then it means the coordinate we are picking is on the right side. So the upper side should be shaded. You see all the borderlines have been plotted now to represent a common region R there. So that's how you plot linear inequalities. We can check number 5, right? Yeah. An inter-county SGR train makes 4 stopovers, each of 3.5 minutes, and 3 stopovers, each of 5 minutes. I hope you are getting that one well. There are some stopovers, 4 of them, each 3.5 minutes, and other 3 stopovers, each 5 minutes. On a certain day, the train left Nairobi at 0802 hours for Mombasa, and the total motion time, read that again, motion time was 5 hours and 50 minutes. 5 hours and 50 minutes. Determine in the 12-hour system the time it arrived in Mombasa. The time it arrived in Mombasa. I'm considering the time in motion being 5 hours and 50 minutes. 5 hours, 50 minutes. Then we shall add, there are 4 stopovers each, for each 3.5 minutes. 4 stopovers, each 3.5 minutes. Then we add again 3 stopovers, each 5 minutes. These are all minutes. So when we multiply 3.5 by 4, we'll get 14 minutes. So these are these 550 hours. Then those are the hours the train was in motion. Then when we add the time it is stopped, there are 14 minutes according to the first 4 stopovers, and the other 3 stopovers are giving us 15 minutes. So what do we get here? We are going to get 79 minutes. 79 minutes means we'll have 19 minutes and 60 minutes will become an hour. So that this becomes 6. So 6 hours, 19 minutes are the total time taken. And the starting time was 0802. So we add the time taken, 6 hours, 19 minutes. You see this is going to be, for the minute side, 21, and for the hour side, 14. So it shall arrive at 14:21 hours, but the examiner is talking about the 12-hour clock system. The 12-hour clock system, which means this is going to be expressed as 2:21 p.m. 2:21 p.m. is the arrival time in 12-hour clock system. Number 6, a very good question. The size of the exterior angle of a regular polygon is 36 degrees less than the interior angle. Calculate the number of sides of the polygon. Look at this relation that the size of exterior of a regular polygon is 36 less than interior. So we can let the interior angle be x, so that the exterior now is x minus 36. One thing we know is that interior plus exterior are supposed to give us 180 degrees. So x plus x minus 36 should give us 180. So 2x minus 36 equals to 180. 2x equals to, when we pick 180 and we add 36, we are getting to 116. So that the value of x after dividing through by 2 becomes 108. Now, if the interior angle is 108, then the exterior angle shall be, 108 minus 36, and this gives us exactly 72 degrees. So it is 72 degrees. We all know that the number of sides is usually given by 360 degrees divided by the size of an exterior angle. So 360 out of 72, this is going to give us 5. 5 sides. So that becomes the answer now. 5 sides. Yeah, 5 sides that way. So you're supposed to know all the properties that govern angles and polygons that way. Looking at number 7 now. Good, we work it together. It's my hope that you guys are learning something tonight. Let's know your school. Let's know where you are watching from. Yeah, you can say hi to mwalimu wa math. Just say hi to your math teacher. Type your regards there. Mention your class and the teacher that handles your mathematics. It will be a great pleasure to read the comments and know where you come from. Otherwise, let's continue learning together. I don't know whether you've already subscribed. I don't know whether you are already inviting your friends from your class. I know you have very many WhatsApp groups. Just share our link there and we shall grow together. Number 7, construct a parallelogram. PQRS in which PQ equals to 8 centimeters and QR equals to 4.6 centimeters. The angle QPS equals to 60 degrees. Then we are told to drop a perpendicular from S to meet PQ at M, then measure the length of SM. Let's do this together. Let's do this together. We start by drawing a very straight line. This one we're going to call it PQ. Line PQ. P. Then we measure 8 centimeters. So measuring 8 centimeters. After 8 centimeters, this is going to be Q. 8 centimeters. Huh? At that point now, we're supposed to know that the angle at P is 60 degrees. And how do we measure an angle of 60 degrees? Or how do we construct an angle of 60 degrees without having to use a protractor? Without measuring this with a protractor, we can construct very conveniently an angle of 60 degrees. And how do we go about it? We just have to start at, you stand at P using a reasonable arc, and you make an arc. Using a reasonable radius, you make an arc. Then you stand at the point where the arc is cutting the line PQ. Standing there using the same radius, you cut the first arc like that. Then when you join that intersection of the arcs, you will have come up with an angle of 60 degrees without a protractor. Like that. This is automatically 60 degrees. So you will have constructed an angle of 60 degrees. Now, with this angle of 60 degrees, ladies and gentlemen, the other thing that you're supposed to know is that this being a parallelogram, opposite sides are equal and opposite angles are also equal. If opposite sides are equal, then we should know that from Q to R, 4.6, then from also P to S, from P to S, yes, from P to S, it shall also be 4.6. So you measure again 4.6 standing at P and you make an arc. 4.6. You make an arc like that. So this is 4.6 centimeters. This is going to be S. That way. So we have point S already. It would be easy now to identify point R, which is our last point. There are very many options. We can just stand at S using a length equal to P, Q, and we make an arc. Then after that, we stand again at Q using 4.6, and we cut the original arc, and we will have an intersection called R that way. Or we can stand at Q. Let me show you another method. I know the methods and the approaches are many. As long as you come up with what you need, you are good to use any. You can stand at Q. You make an arc. Remember, I want to construct 60 degrees here. Standing at the arc, you cut the first point. Then now you produce this line. So this will be another 60 here. Producing 60 at that point, you will have made PS and PR parallel to one another. Then you stand now to measure the same length from Q to R of 4.6. So with a radius of 4.6 centimeters, you make an arc. This becomes point R. So point R and S can now be joined using a very straight line there. Using a very straight line, join like that. See? Very simple thing. Very simple thing like that. So we have the parallelogram already constructed. Then what else are we told to do? We read again the question. Drop a perpendicular from S to meet PQ at M. So standing at S, we are supposed to drop a perpendicular. We are supposed to drop a perpendicular. So we stand at S, dropping a perpendicular from a fixed point to a given line. You stand at S and you make an arc. You can make an arc at that point and also cut the same line at this point. Then now standing on those particular arcs, you can make more arcs actually to intersect either below or above the line. So with this now, a perpendicular line can be dropped. And we are told where it cuts PQ, this is M. Then you measure SM. Those who are very careful and constructing accurately, you shall discover that S to M is exactly 4.0 centimeters. This we can allow an accuracy of plus or minus 0.1, such that if a student is having 4.1, we consider them. 3.9, we also consider them. But that's how you are supposed to work it out. Now we proceed to the next question, right? This is number 8. What are we told in number 8? To find the value of y in the following equation. 5y minus 1, 5 power 2y minus 1, then plus 5 power 2y equals to 150. This is a very good equation from indices. You're supposed to be solving it very carefully. Very carefully. Look at this. The first thing that you're supposed to do, guys, is to ensure that you apply the laws. You apply the laws of indices. The first law says, in case you are having a power m, then you divide this by a power n. That's the same base, different powers. You just take a and you subtract the powers. So we shall apply that in the first term of this equation, such that if 5 is raised to power 2y minus 1, then it means we add 5 power 2y, then this was divided by 5 power 1. That is why at the end of the day we are having 5 and the powers subtracted, plus 5 power 2y equals to 150. So at this point now, we can let 5 power 2y, which is appearing in two different cases, be a certain unknown. Talk even about t, such that t over 5 plus t equals to 150. Now I'm rewriting the equation. T over 5 plus t equals to 150. You see, this is a fifth, in other words. So a fifth plus 1. This is 150t now equals to 150. So how can we get t? When we take 150 and we divide by 1 and 1 over 5. This is going to be 125. So what had we let to be t? Whatever we had let to be t is 5 power 2y equals to t. And what is t? 125. So 5 power 2y equals to 5 power 3. That is after changing 125 to base 5. So if the bases are the same, now we can equate the indices. 2y is equal to 3, meaning that, or implying that, the value of y is equivalent to 3 over 2, which is 1.5, or 1.5, that way. So you see, we are there already having the values of y properly calculated. Ladies and gentlemen, mathematics is very simple, easy to understand, and I request you to just follow up with our programs, and by the end of the day, every student shall come out with a good grade. Invite your classmates, invite your friends from even other schools. Let's learn together in Shifting Grades Online School. Now at number 9, graphical question. We are taught to use the Cartesian plane provided to find the point of intersection of the simultaneous equations below. To find the point of intersection. So for us to find the point of intersection, we are supposed to plot the two equations on the same Cartesian plane. The two equations on the same Cartesian plane. After that now, we are going to interpret the point at which they shall be intersecting. So let's begin with the first line. The first line, y equals to negative 2 over 3x plus 4. So a table of values, x and y. Because of time, allow me to use the intercepts again. When x is 0, what is the value of y? 4. Because when x is 0, we substitute 0 in the equation. I don't know whether you are getting that. When x equals to 0, we just substitute 0 at the point where there is x. Then it becomes y equals to 4. Then what about when y equals to 0? So when y equals to 0 now, the same equation becomes 0 equals to negative 2, that's x plus 4. So we can remain with 4 at this point and have 2/3 x coming to this side. So that to remain with x, we have to multiply by 2/3 both sides. We multiply by 3 over 2. So this is going to be 6. That way. So that's how we are supposed to work it out. You just find the intercepts that way. So with this table now, we can plot the first line. Let's plot the first line. Remember, on the Cartesian plane, everything has been labeled for us. Ours is just to apply. So these are very fair examiners. Very fair examiners. 0, 4, that is for the y-intercept. 0, 4, that means we come to this point. Then we are having a 6, 0. 6, 0 at that point. So now we can place our line. First line can be placed now. The first line can be drawn. Let me draw it and even use a different color. Yeah, blue. That one. So we have the first line already drawn. Let's go to the second line. The second line is a x minus 3y plus 3 equals to 0. X, y. At x equals to 0, what shall be y? And at y equals to 0, what shall be x? So at x equals to 0, the equation becomes 0 minus 3y plus 3 equals to 0, meaning that negative 3y equals to negative 3. And this means y equals to 1, positive 1 that way. Then again, when y equals to 0, the equation becomes x minus 3, y is a 0, plus 3 equals to 0. So x plus 3 equals to 0. The value of x will become negative 3. X equals to negative 3. So I'm dealing with 0, 1 at this point. And also, I'm dealing with negative 3, 0. Negative 3, 0 at this point. So now we can do the second line using the intercepts. I'm giving you a secret. Using the intercepts making your work very easy. It makes your work very easy. So now we can plot the line. The second line is now plotted. After that, ladies and gentlemen, you can discover that there is a point of intersection here. A point of intersection. So what we were finding is to find the point of intersection for the equations below. So the point of intersection is going to be 3, 2. That is the answer. Finding a point means giving a coordinate. Giving it as a coordinate. Very easy. You give us a coordinate like that. So a student who moves ahead to say that x equals to 3, y equals to 2. This one is the simultaneous solution of the two equations. But now, were we after that? No, we are after finding the point of intersection. The point of intersection. Very easy. So it's already done. Yeah, we can proceed. And proceed to the next question. The next question is a number 10, which looks a very good question. A circle of radius 5 centimeters is inscribed in a regular pentagon. Inscribed in a regular pentagon. Then what is the next? Determine the area of the pentagon that lies outside the circle. Area of the pentagon lies outside the circle. So we have a circle. We can sketch the information anyway. Let's sketch it. We are having a circle. We are having a circle. And this circle is inside, it is inscribed in a regular pentagon. So a 5-sided figure is such that the circle is inside, it is inscribed. It is inscribed. A regular pentagon. How many phases are here? 1, 2, 3, 4, 5. Yeah, that one. It has been inscribed. So what do we want? The area of the pentagon that lies outside the circle. So that lies outside the circle means we need the areas at these points. We need the areas at those points. So we can take the area of the whole pentagon, minus the area of the circle, because the circle is inside the pentagon. Then by taking the whole pentagon, then we subtract the circle, we will get the shaded area, which is the area of the pentagon, outside the circle. All that. So let me approach it this way. For the pentagon, you know, there is a radius of 5 centimeters at this point. So let me first Let me first talk about the center of the circle, like that. So this pentagon can be divided into five equal triangles. 5 equal triangles. And if it can be divided that way, then it means it will be very easy for us to find area of one triangle, then we multiply it by 5 such triangles. Because being a pentagon, it can be divided into 5 of them that way. 5 equal. So when you divide into 5 equal, at the center of each triangle, we can get the angle there by taking 360 over 5 of them, 72. So we are having a triangle like this. Whereby there is an angle of 72 at this point. Then something else that you're supposed to know, according to how the circle is passing, then the length here is the one which is known. The length there is the one which is known to be 5 because it is equal to the radius. So this is 5. It's 5 centimeters. If that is 5, then we can get the angle from the center to, let's say this is AB. We can get OB by using 36 after dividing by 2. So we can say the cosine of 36 equals to 5 over the length OB, because it should be adjacent over hypotenuse. So OB times the cosine of 36 equals to 5. So that will remain with the length OB. We need 5 over cos 36. What are we getting here? 5 divided by cos 36. I'm getting 6.18 to 2 decimal places centimeters. So if we have that dimension, then we can say the area of this triangle, equals to half 6.18 times again 6.18 the sine of 72, half AB sine of theta. So half times 6.12 times 6.12, the sine, because the area should be half AB sine theta. And theta is the angle between the two sides. So I'm getting 18.16. Then now, area of the pentagon, for the whole pentagon, because this is one triangle. Area of pentagon is going to be 18.16 by 5, because they are such 5 triangles. And I'm getting 90.8. 90.8. Yeah, 90.8. 80 centimeters squared. This is area, centimeters squared. Now with the area of the pentagon, we can get area of circle now. Area of circle is given by pi r squared. So pi r squared. And this is going to give us 78.57. square centimeters. Now that we have area of the circle and we have area of the whole pentagon, then we can get area outside. Area of the pentagon, which is outside the circle. So area outside the circle now, the intended area shall be 90.80 minus 78.57. This is going to be, I'm getting 12.23. Square centimeters. So you really had to think in this particular question. You really had to reason out for you to understand what the examiner is looking for you to follow through until you find the right answers. So it's a very good question, yet it requires a thinking student. For you to first of all sketch the information. You interpret the information from statement to a diagram. Then you proceed with that particular diagram now. You proceed with that particular diagram until you find the area that we needed. All right. At number 11 now, again, graphical work. Look at what we are being told. We are told that vectors P, Q, R are represented in the grid below. We have vector P, Q, and R, as you can see them. On the same grid, show the resultant vector P plus Q minus R using point O as the origin. So we can already see point O. For us to add vectors or subtract, we are supposed to start with the original vector which has been stated first, that is P. Then at the head of P, we shall attach the tail of Q. At the head of P, we attach the tail of Q. So let me start by drawing vector P with the O as the origin. So P is supposed to occupy 3 units, 1, 2, 3 horizontally, and 2 upwards, 1, 2. So P shall move this way without changing the size of P. So that is vector P. It should be having an arrow. That is vector P at the origin. Then at the head of P, now I bring the tail of Q. Q is here. So Q should be 3 units toward the right, 1, 2, 3, and 1 unit downwards. So I'm supposed to attach and move 3 units against 1 downwards. That way, up to this point. So now, Q is here. It has been attached there. Then we proceed to do what? To subtract R. Look at R. R is already 1 unit to the left and 2 units upwards. So when we reverse R, because we're talking of not plus R now, but minus R will be the same size, but moving in the opposite direction. Minus R means the same size, but in the opposite direction. So we shall attach the head, the tail of R at the head of Q, such that now we start at Q, but we shall move only 1 unit to the right and 2 downwards. This way. So R shall be brought here, but this way. Because we are moving in the opposite direction, we are subtracting R. If it was addition, we would have moved in the opposite direction. So that is where R is. Vector R. That way. That is vector R. So with all this now, we can summarize the whole vector. Though we are already done, we are already through, but we can tell ourselves that P plus Q minus R is now generally, you can now check the final displacement now. The final displacement from where we started to where we are ending. Yeah, that way. So generally this one is going to be P plus Q minus R. P plus Q minus R, that way. So that's how we handle the vector. Very simple question for 2 marks. Number 12 now. We are now at number 12. Again, a very good question. The examiner is telling us to write an expression in terms of X, Y, Z for the total value of a 3-digit number, X, Y, Z. So if we have a 3-digit number, X, Y, Z, it means Z is at once. So the value of Z is Z times 1. The value of X, of Y, which is in tens, should be Y times 10. And the total value of X should be X times 100 because it is on the hundreds position. So now the expression shall be 100X plus 10Y plus Z. Z is on ones. So it is Z times 1. So this is the total value of the number. Let me continue expanding this expression. When you are told, for example, a number is 286, for example, the value of this number is 2 is in hundreds position, so it's 2 times 100. Then 8 is on tens, so 8 times 10. Then 6 is in ones, 6 times 1. That's how we are getting 286 because 2 times 100 becomes 200. 80 times 10 becomes 80. 6 times 1 becomes 6. Therefore, when you add up everything, you are getting 286. That's just an expression to show you how I have split this one into the expression that the examiner wanted. That way. Look at part B. Look at part B. The number in A above is such that the sum of its digits is 13 and the tens digit is 2 less than the unit digit. When the digits are reversed, the number increases by 297. Find the original number. So we're going to use the space now here for us to work out this problem. Let me start interpreting at the space up there. Then we shall proceed with the space below. All right, the number is such that the sum of the digits is 13. So when we take X and we add Y, then we add Z, we are getting 13. This is one equation. We proceed again to interpret. We also told that the tens digit is less than the tens digit is 2 less than the units digit. So the tens digit is Y. Y equals to 2 less than the units digit. Unit digit is Z, the ones digit. So Z, we should add 2 for us to get Y. Yeah, for Z, we should add 2 to get Y. I hope that interpretation is right, unless we reread. The tens digit is 2 less. 2 less than the ones digit. So ones digit is greater by 2 than Y. Z is greater by 2 than Y because Y is less by 2. Y is less by 2 than Z. So Z is greater by 2. Yeah, That is it. So that's another equation, which means again that y can be replaced with z because they are related. So equation 1 can be rewritten actually from that particular statement now. From that particular statement, we can rewrite equation 1 such that x, instead of y, we are having z plus 2, then plus the other z equals to 13. Can we simplify this further? Yes. X plus 2z equals to 11. X plus 2z equals to 11. That will. So this is equation 1 simplified. Equation 1 simplified. Let's proceed. When the digits are reversed, the number increases by 297. When the digits are reversed, means now they begin with z, y, x, like that, whereby the total value now is becoming 100z, because z is occupying the hundreds position. We add 10y, we add x, that way, that is the total value. So we are told that the number increases by 297. So this new number minus the original number, we're supposed to get 297. This is the second equation, but we can simplify it first. So 100z plus 10y plus x minus 100x minus 10y minus z equals to 297. Grouping of terms means we can start with the z. 100z minus z means 99z. Then 10y minus 10y means y can cancel out. Then x minus 100x means negative 99x equals to 297. That way. This is the second equation, which can also be simplified. By 11, I will be getting 9z minus 9x equals to 297 over 11. This is 27, which means we can further simplify by 9 to get z minus x equals to 3. Second equation simplified. Yeah, second equation simplified. So this equation is in terms of x and z. The first one is also in terms of x and z. So from equation 2, what is the value of z? 3 plus x. This is from equation 2. This is from equation 2. Then if that is so, then it means we can rewrite equation 1 because we want to solve them simultaneously. X plus 2z. X plus 2 instead of z, 3 plus x. That one was equal to what? That one is equal to 11. Equals to 11. So x plus 6 plus 2x equals to 11. This is a 3x equals to 5. Is that right? 3x equals to 5. Yeah, 3x equals to 5. But I can see it shall not be divisible. I don't know where we are making the mistake such that we get No, I will check. I'll check it out slowly. I'll check it out slowly so that I see where we are making the error, where we are getting the mistake. Because if I proceed here, it means I'll be having 3x being equivalent to 5. And you see, we can now not get a digit here. So, see, they should be digits. They are supposed to be digits. They are supposed to be digits. Supposed to be digits. So I will check the source of mistake in this particular question. Then we solve it. Let's check number 13 first. So we are going back to number 12 to clarify where the mistake is coming in, because we must ensure that we get digits. We must get digits. Solve the equation for the sine squared of 2x equals to 3. Then the range of values of x to be from 0 to 90. The first thing we're supposed to do is to say that sine squared of 2x equals to 3 over 4. I've divided by 4 through. If that is so, then it means the sine of 2x is equivalent to the square root, because I've obtained the square root now, equals to the square root. For the denominator, the square root becomes 2, but for the numerator, just have it as root 2. So there are some angles which will satisfy this equation, because we need to say that there is an angle theta which will be given by the sine inverse of root 3 over 2. Root 3 over 2. This is going to be exactly 60. So we are going to deal with an acute angle of 60. That is what we shall equate to 2x. So we can conclude that 2x is equal to, we want an acute angle of 60 at the quadrants where signs are positive. Where signs are positive. So where are signs positive? Signs are positive in the first and the second quadrants. So when in the first quadrant, 60 shall be written as it is, but in the second quadrant, 60 shall be written as 180 minus 60, which is 120. Then, in case we make a complete cycle, we can start now finding other possible angles, such that, let me show you. This is the unit circle. That way. All of them there, the first, then sine alone, tangents alone, and cosines. So we are saying 60 here will be measured as theta, just the way it is. But in the second quadrant, we measure it as 180 minus theta. In case we were dealing with a third, we would measure it as 180 plus theta. And here in the fourth, it's measured as 360 minus theta. So we just wanted the first two quadrants. In the first, as 60. In the second, as 180 minus theta. So what are other possible angles whose trigonometric ratios shall behave like these ones? We need to take 360 and we add to the first angle, giving us 420, like that. We can proceed. We can also take 360 plus 120, like that, to give us a 480. The angles continue. So the value of x shall be, when we divide everyone by, or each of them by 2, then when you divide 420 by 2, you shall discover that the angle is greater than 90. So they are only 2, because the others will be beyond the given range of 0 to 90. Yeah, 0 to 90. like that. So those are angles that satisfy the equation above. Number 14. Check number 14. Remember, we'll be getting back to number 12. Don't switch off. We're getting back to number 12. Number 14. The total number of students that attended a contest, a science contest, was 1,200. Mathematics had twice the number of students as physics. Then chemistry had 100 students more than physics. You see now this information is rotating around physics. When the information was represented in a pie chart, biology had 60 degrees. Determine the number of students that attended in each of the 4 science subjects. The 4 science subjects are mathematics, chemistry, physics, and biology. So let's let physics be X. We can let physics be X. If physics is X, let's read slowly. Mathematics had twice the number as physics. So it means math shall take twice the number in physics to X, while chemistry had 100 more than physics. Now chem shall take 100 more than physics, means X plus 100 that way. What about biology? Now biology is having 60 degrees in a pie chart, which means 60 over 360, which is the total degrees, to give us the fraction of biology times 1200. So for biology, we can get the number direct now. 60 by 1200 out of 360, giving us 200 students who sat for biology. Yeah, this one's took biology. 60 students took biology, 200 students. That means the other 3 sciences now are sharing the remaining, which is 1,000. So when we take X and we add 2X, then we add again X plus 100, we are supposed to get the other students now who are 1,000, because biology alone is taking 200. Then the remaining students are 1,200, and they are going to the other subjects. So when we add up, this is 4X equals to 900. So the value of X shall be, we take 900 and we divide it by 4. This gives 225. 225 students. This one will sit for physics. Sorry, physics is already written, so we write 225. Then for mathematics, it shall be, we multiply this number by 2. This is 450. Then for chemistry, we add 100 to 225. 325. So let's check whether these numbers are aligning. 225, we add 450, then we add 325, and we add the 200 students in biology. I'm getting 1,200. So that's how the students were split into the different subjects for the contest. The biggest task was to identify what does 60 in a pie chart represent. It is 60, and the total degrees in a pie chart are 360. So 60 over 360 would give us the fraction that goes to biology. Then we multiply that by the population, which is 1,200, that attended the whole contest. So we started by getting the specific number of students who sat for biology. Number 15. In the figure below, O is the center of the circle, and the angle OAC equals 36, just as you can see, was 36. Find the size of angle ABC and also the size of angle BCA. Okay, let me first find the angles that I can. The angles that I can find. Remember, this side and this one are equal from the center to the circumference. If they are equal, then it tells that this is also 36. If that is also 36, then it means we can get the angle at the center here. The angle at the center there, 36 plus 36, giving us 72. 180 minus 72, giving us 108. So the angle at that point is 108. If that angle is 108, there is something that we're supposed to learn here. That the angle at that point up there shall be half of this, which is 54. This angle is 54. If this angle is 54 degrees, then we can get the opposite angle. That place can be called D. If we call that one point D, then D and B are opposite angles in a cyclic quadrilateral. ABCD is a cyclic quadrilateral. So we can get the opposite angle now, 180 minus 54. So the angle here is 126. The angle there is 126. I'm using angle properties of a circle that way. If that angle is 126, let me check the angles we were finding. I don't know. I'm just filling angles there, but I had not checked the specific angle that we are finding. ABC. The angle ABC means the size of 2x, in other words. So when we take, because now ABC is a triangle, when we take 2x plus x and we add 126, we are supposed to get 180 because it is inside a circle. So 3x equals to, we take 180 and we minus 126, whereby we are getting 54. So the value of x shall be 18 degrees. Now, if the angle is x is 18 degrees, then the angle ABC shall be 2 by 18, giving us 36 degrees. What about the angle BCA? BCA is the value of x, which is already discovered. 18 degrees. It's already identified as 18 degrees, and that's why we are having it as 1 mark, because it has already been worked out. Can now proceed again to the question number 16, which is the last question in the section 1. Yeah, next week it will be for section 2s, but this week we have really majored on section 1. Tomorrow we'll be doing physics paper 1, color joint examination. Yeah, number 16. The figure below represents a triangular prism, which is a ABCDEF. X is the mid of line. It's the mid of line BE. That way. Draw the net. It's good for you to know that drawing a net requires you to make real measurements. Real measurements, and something else that you're supposed to know is that you are supposed to open up a solid such that in case you fold back the net, you will get your solid back. You will get your solid back. So if at C, there is some mathematics here that I want us to apply. If at C, it is right angled, then it means, we are having 3 and 4 here. So it means the length AB can be found by taking 3 squared plus 4 squared, the square root. So we'll be doing the square root of 9 plus 16, which is 25. So 5 units. So this is 5 centimeters. This is 6 centimeters, 6 centimeters. So now we can draw the net. We can begin by drawing the base, which is a ABEF, which is rectangular, 5 by 6 or 6 by 5 centimeters. 6 by 5 centimeters. You will allow me to sketch the net, but in your case, I expect you to use real measurements. I expect you to use real measurements. So what are we having here? So the base is BE F A. Yeah, that way. So we have the base. This one is measuring 6. This one is measuring 5 centimeters that way. Then at this point now, when you stand at F, let me show you. When you stand at it's good to know that EDF is the same as BC. Those two triangles, they are the same. The triangle on the left and on the right. So this is also going to be 4. This is also going to be 3 automatically. Then this is going to be 5. So that's something you're supposed to know. There are 2 equal triangles, and I want to draw them now. So you just stand at F and you use 3 centimeters. Stand at F, you use an arc of 3 centimeters. You stand at E and use an arc of 4 centimeters. That way, the intersection is going to give us point D. It's going to give us point D. It shall automatically be right angled. That way, it shall automatically be right angled. So that is point D. You do the same, standing at A, you use 3 centimeters, and standing at B, you cut like that. So this is going to be, that was D, so this is now C. Again, right angled. Automatically it shall be right angled. As long as you use 3 centimeters here, 3 centimeters here, then from B, 4 centimeters, and also from E, 4 centimeters. So we have the base and we have the triangular faces. How many triangular faces, or how many triangles now? How many faces have we not drawn now? We have the right angle, we have the rectangle ACDF 3 by 6. So we can measure 3 here and 3 here. So 3 centimeters, 3 centimeters. This is automatically 6 centimeters. And now we shall get C and D at this point. Then now on the lower side, we also insert the rectangle that measures 4 by 6. 6 is already in place. So we just have to measure 4 and also 4 here. Then you connect left. So this is 4. This is 4. Then we are having a CD again. CD like that. So you see, this is now the net. The solid has been fully opened. And after we have fully opened it, you can check now. In case we close it back, we shall get our prism because we have the 1, 2, 3, 4, 5. We have the 5 faces opened. So the 2 triangles, the 3 rectangles, like that. So that is the net. And I've told you, and I'll tell you again and again, that for you to get a good net, just ensure that all the faces are opened up. Ensure that the net, you can count each face. 1, the base. 2, 1 triangle. 3, another triangle. 4, a rectangle. 5, a rectangle. The solid is made up of those triangles. So you have now opened it that way. Now we get back to the question that we left hanging somewhere before we wind up. Remember to subscribe, remember to share, remember to invite friends to this platform. Remember to invite friends to this platform. Now we are back to our question number 12, which I want us to clarify a few things before we wind up with our lesson. we are going to do it slowly. Now that it is the last one, there is nothing else that we are solving. After this, we shall be resting. So be patient until we work it out together. I don't know whether you are inviting a friend to our platform. I don't know whether you are talking about our program on Shifting Grades Online School. I don't know, but it's something that you should be doing. Please make sure that you refer friends to our August holiday assignment. Our number, I just repeat, it has already been attached here, 0704 15 3366. That number is going to help you. Please reach out so that we may continue learning together. We proceed now. Write an expression in terms of x, y, and z for the total value of a 3-digit number x, y, z. So I've said an expression for the total value means x is at 100's position. So that's why we have 100x plus 10y because y is in the 10's position plus z because z is in the 1's position that way. Then we are told that the number in A above is such that the sum of its digits is 13. Sum of the digits means literally, if you take the first digit as x and you add the second digit as y, then you add z, you are getting 13. That is what it means. We are getting 13. That is the interpretation. What else are we told? That the 10th digit, you know the 10th digit is y, is 2 less than the unit digit. The 10th digit, which is y, is 2 less than. So in other words, it is smaller than z. Y is smaller than z by 2. Y is smaller than z by 2. So for us to get y, we need to take z and we subtract 2. I think that is where we made a mistake. We did an addition there. That is what we are supposed to interpret. The 10th digit is 2 less than the unit digit. So y is less than z by 2. So for us to get y, we need to take z and we minus 2 that way. So with this, we know we have the first equation here. So with this statement, we can also re-express the first one. X instead of y, z minus 2, then plus z again, equals to 13. So this can mean z or x plus 2, z plus 2, okay, x plus 2z is equal to 15. This is now equation 1 simplified to some extent. Yeah, simplified to some extent. Let's now continue reading out the question. When the digits are reversed, the number increases by 297. The number increases by 297. So if the number increases by 297, when reversed, it means the number now becomes z, y, x, meaning that the value of this number is 100 z because z is taking the 100's position plus 10y plus x. That is now the new number. So what equation are we solving here? Or what equation are we forming here? We are forming an equation that says, in case we take the new number and we subtract the original number, whose value is this? We are supposed to get 297. If that is so, then it means 100z plus 10y plus x, then minus 100x minus 10y minus z, we're getting 297. At this point now, we can group terms. 10z, 100z minus z gives us 99z. Then 10y minus 10y, that one cancels out, minus 100, x minus 100x becomes negative 99x, equivalent to 297. This is equation 2, but this equation can be further simplified because 99 can divide through z minus x equals to 297. I divide it by 99, I'm getting 3. So this is simplified equation 2. So we can solve 2 and 1 simultaneously. From equation 2, the value of z equals to 3 plus x. And if it is so, then we can rewrite equation 1, which will be x plus 2 by z, which is 3 plus x. Yeah, equals to 15. X plus 6 plus 2x equals to 15. This is 3x equals to 9, meaning that the value of x is 3. If the value of x is 3, then we can get the other values because z is here. Z can be found as 3 plus x, which is also 3, 6. Then y can be found by going up. Say that y is given according to this expression. So the value of y shall be z minus 2. Z, which is 6 minus 2, this is 4. So the original number is xyz. xyz means original number. xyz means 3, 4, 6. xyz, which is 3, 4, 6. I think that is true now. 346. So if the original number is 346, what is the new number? 643. What about when I subtract them? 643 minus 346. I'm getting 297. Wow. So this is the final answer. So thank you so much for following. Sorry for the mistake that occurred. We are now through with the question. Thank you for following up with the whole paper. See you next time for a physics discussion.